Hi, I'm Dennis Engel. I'm a professor at Mohawk College. I teach project management. Today, we're talking about dependencies. Something depends on something else being done. Something has to be done first. And you can call it a predecessor is the first thing, and a successor is the second thing. For example, we're building a house. So we're going to put plywood on the top of the house, and then we put shingles on the roof. We have to put the plywood on first, then we put on the shingles. So the plywood is a predecessor. The task of putting on the plywood is a predecessor to the shingles. Go. Using Microsoft Project, we're looking at the Gantt chart. On a Gantt chart, all the tasks are represented by blue bars like this. When we put in a predecessor, then the successor has an arrow, so that we get something like this. This arrow tells us that this task must be done before this task. If we don't have a predecessor, then we could start the tasks at the same time, and they would both be back at the same day, because we want to get things done as soon as we can, and we can move things as early as possible. So by putting in predecessors, tasks move later in the timeline, and it will definitely lengthen our project. Another predecessor, another type of dependency, is start to start. We've already talked about finish to start. Task A must finish before task B starts. But there's another case where two things need to start at the same time. We're making a cake. You're putting in the water and flour, I'm stirring. They are two tasks. They must start at the same time. I must start stirring as soon as you put it in. You're painting the room. I'm looking after ventilation. I must ventilate the room at the same time as you're painting. We both start at the same time. So a start to start dependency for two tasks. They must start at the same time. Here's another dependency. The third kind is finish to finish. Two tasks that must finish at the same time. We're building software. We're constantly changing the new software. We're developing it. We're also testing it. Every time a test uncovers an error, we have to fix it. We have to develop it some more. So if the top one is developing and the bottom one is testing, when are you finished? Well, they're finished at the same time. And we'll get a dependency that's called finish to finish. When I'm finished developing, I'm finished testing. When I'm finished testing, I'm finished developing. Finish to finish dependency. The fourth kind of dependency is start to finish. It's backward. I can't finish until you start. This is your task out here. It's in the future. Your task is to connect the electrical wires from the road to our new house. My task is to run the generator. When do I stop running the generator? I stop running the generator when you start the electricity coming from the road. In this case, we make the arrow go backward. So this can't finish until that starts. If this moves forward, this is going to move forward. Okay, now we're going to talk about lag. Suppose we have a normal finish to start dependency. We're going to lay a pipe in the ground. We dig a big long trench, finish, then you can, and only then, you can start putting pipe in the trench. When you're finished putting in the pipe, then we cover it in with dirt. So far so good. Well, it's okay if the trench is 10 feet long. But think about a big pipeline with a trench going all the way from Hamilton to Alberta. It'd be kind of dumb to dig the whole trench and then wait and come back and put in the pipe. So our normal finish to start dependency looks like this with the arrow. And when the digging the hole is finished, then we can start the task that involves putting the pipe in the trench. Let's change this. Okay, in this example, this is our task for digging the hole. But it would be reasonable to have just part of the hole dug, and then we can start putting in the pipe. Let's imagine that the two tasks progress at the same rate. If this happens over a month, consider this. You're the digging the hole, I'm putting in the pipe. I'm going to let you have 1 day head start. So you start on this task that takes 1 month, but as soon as you're 1 day into it, I'm going to start my task of putting the pipe in the trench. All I have to do is stay 1 day behind you and everything works out great. And when you're finished digging the last little bit, the next day I put the pipe in that last little bit of trench. In this case, this is still a finish to start, but with a lag. So we consider the lag in here to be 1 day. In this example, we have a task of digging the trench for the pipe. Let's imagine it takes 1 month. So it takes 1 month to dig a trench. Let's also imagine that putting the pipe in is done at the same rate. It's also going to take 1 month. Well, now, what we can do to compress the time. If we don't compress the time, it's going to take 2 months. One task to dig the trench and another task to put the pipe in, and it starts out here. But consider this. Let's dig the trench for 1 day. And as soon as that day is over, the next day, I start putting pipe in that. The person on this job also starts digging the trench on day 2, but I can start putting pipe in the trench that was dug the day before. In this case, we're still going to call it a start-to-start dependency, but in this example, it's going to have a 1 day lag. This task will lag 1 day behind this. You'll also find lags where we have to wait for the concrete to harden, we have to wait for paint to dry, and different things like that. In software, for example, if this task is testing and this task is development, in some cases, I can start testing 1 day after you build something. So what you did yesterday, I can start testing today. And we can call that a start-to-start with 1 day lag.